So today we are going to be discussing symmetry as well as dilations. And so let's start off by talking about the three different types of symmetry. So line symmetry essentially means that if you can draw a vertical, horizontal, or a diagonal line through any figure and you can cut it completely in half so that if you were to fold the figure upon that line that it would fold right on top of itself. So for instance, this figure right here, I could actually draw a vertical line of symmetry right, whoops, let me actually use a straight line. Here we go. So I'm going to draw a vertical line of symmetry right through it right here. Now clearly I can't show you, but if I were to fold this side over onto this side, it would fold right directly on itself. So this figure has line symmetry. If you look at this figure here, it does not have line symmetry. Even if you tried to draw a diagonal line through it, this side would not fold directly onto that side. It would not be a perfect match. But this end does have point symmetry. So for a figure to have point symmetry, it must be able to map onto itself. In other words, you've got to rotate it and turn it within or exactly 180 degrees, and it looks identical to itself. So I'm going to put a little dot right here so that you can see that that's our top, and I'm going to attempt to rotate this. Let's see if I can rotate this 180 degrees. And there you go. So you can see it still looks like an N, and I've rotated it 180 degrees. You can see, whoops, you can see that my line symmetry did not move with the picture, which is fine. Let's see if I can move. Oh, look, well, that's fun. Okay, we're just gonna get rid of that sucker. Wait, maybe. Oh, this is always fun. Well, all right, we'll ignore that. Okay, so then rotational symmetry means that if you can take a figure and rotate it within 360 degrees, which is one full turn of the circle, onto itself, so it just has to become itself within that 360 degree turn, then it is considered to have rotational symmetry. So, for instance, I'm going to put a dot right here, but you can see, and that's just going to show you how far we're going to rotate it. You can see that as long as I rotate it, we're going to rotate it one click over here. You'll see that it's going to look identical. We have a triangle here, a triangle here, three over here, and three over here. So here's what's going to happen. Let's rotate it. Whoops, I don't even want to rotate it that far. I'm just going to rotate it one click there. So now this is facing directly up, but notice I have a triangle here, three over here, and three over here. So 1, 2, 3, 4, 5, 6, 7, 8. If I took 360 degrees and divided it by 8 to figure out what that was, it would tell you how many degrees we had to rotate it to get that symmetry. So let's rotate that back. All right, so then what I want you to do is look at each of these figures. I'm going to go through the first 8 with you, and then I'm going to have you do the next page on your own, which would be 9 through 20. But we'll go through the first 8 together, and then you can determine the rest of them on your own. So for number 1, for it to have line symmetry, you just have to find one line that you could cut through it, and I can actually do several. I could cut it in half this way. I could cut it in half this way. Whoops, I missed it just a smidge. Let's try that one more time. Now I want above, but you get the idea. I could cut it there. I could also cut it diagonally, so I'll cut it one more time. So this one has a lot of different lines of symmetry, so I could cut it diagonally there, and it would fold onto itself. So this definitely has line symmetry. For it to have point symmetry, we just have to rotate it 180 degrees. So I'm going to get rid of these lines. All right, so I'm going to put north right here, and we are going to rotate this 180 degrees and make sure that it looks just like itself. So here it is, rotated 180 degrees, and it does indeed look just like itself. So I'm going to rotate that back. And we're going to check this, saying that it has point symmetry. Then for rotational symmetry, I just have to rotate it however many degrees within 360 to see if it's identical. So I'm going to go ahead and keep the N right where it's at, but let's see if I rotate it here. That looks not quite identical. I only say that because these are not quite opposite each other. I don't know if it's just bad drawing on their part, whoops, but I can turn it to 180 degrees. Pretty much if it has point symmetry, it's gonna have rotational symmetry, just an FYI. It could have rotational symmetry, but not point symmetry. But I'm trying to think, anytime it has point symmetry, it should have rotational symmetry. I can't think of any time that it wouldn't. So this we're gonna mark as having rotational symmetry. All right, so it has all three. Then let's look at number 2. So number 2, it definitely has a line symmetry because we did that above, but I'm gonna put a line directly through it here. And so that's where we can cut it into half. So it has line. For point symmetry, we have to turn it 180 degrees. So here's where north would be. And so I'm going to turn it. Wow, the line stuck with us. There's 180 degrees, and you can tell the point is no longer straight up. So it does not have point symmetry. But does it have rotational symmetry? So if I turn it, keep turning it, keep turning it, keep turning it right there, doesn't it look just like itself? And we've only gone not a full circle, not even a half a circle. So it definitely has rotational symmetry, just not point symmetry. So that's all right. We're going to mark that. All right, let's look at number 3. So number 3, there's no line that I can draw through it where if you fold it on that line, it will look identical to itself. So it does not have any line symmetry. And if you don't believe me, go ahead and draw a line, fold your paper, and see, and hold it up to the light and see if it folds onto itself. But this figure definitely does not have any line symmetry. As far as point symmetry, let's go ahead and put an N right here. Remember, to get point symmetry, we have to rotate it a full 180 degrees for it to look like itself. And I just want you to note that notice how the upper right is overlapping the lower right here. Let's turn it back and let's turn it back and see if that's the same thing. And sure enough, as you can see here, the upper right is overlapping the lower right. So it definitely has point symmetry. So we're going to mark that. And as I said before, if it has point symmetry, it automatically has rotational symmetry because you just have to rotate it within 360 degrees. So number 3, we're done with that. Let's look at number 4. So number 4, it does not have any line symmetry. There's no way I can draw a line through it for it to fold onto itself. For point symmetry, I'm going to put a north right here so we know that that's the top. And I'm going to rotate it 180 degrees. It definitely is not the same figure because the right angle is up here. It used to be down here. So it does not have point symmetry. And for it to have rotational symmetry, you have to rotate it within the 360 degrees to get onto itself. And nowhere does it do that. So if I rotate it, notice where the right angle is. See, it's in the lower left. If I rotate it, when does it get back to the lower left? You getting dizzy yet? Now, and that was a full 360 degrees, so that does not count for rotational. It has to do it within, and it has to do it before you hit the 360. So this one has none. All right, so let's look at 5. So 5, it definitely has line symmetry, and I can draw a line through here. And if I made it straight, see if I can straighten it up a little bit, that's better. So there's my line symmetry. If I can get it off there, I don't know. And so I'm gonna mark that, yep. For it to have point symmetry, I'm gonna put a north here, and we're gonna rotate it. Yay, it stuck with us. And is that identical? Look up here, notice that the point right here where the north is should be facing straight up. Look what happens when we rotate it 180 degrees. Now notice that this point right here is not facing straight up. So it does not have point symmetry. Now for rotational symmetry, you just need to rotate it within that 360 degrees for it to look like itself. And there you have an arrow or a pointy part up top. And notice that down here at the bottom, there's no pointy. You've got one to the left and one to the right. So I'm going to rotate right back here and prove to you. Notice we have the pointy part of the star here, no pointy part here, one to the left and one to the right. And I just had to do a click, just a smidge right there, and it rotates back into itself. So number 5 definitely has rotational symmetry. So we're going to mark that and move on to number 6. Number 6 is a fun picture. It does not have line symmetry. You cannot draw a straight line through it and have it fold onto itself. So for point symmetry, let's mark an N right here. And then I'm going to rotate it 180 degrees. I want you to note that this curly Q is in the upper right. That curly Q is in the lower left. So let's go ahead and try to rotate it 180 degrees. And notice that this curly Q is in the upper right. That curly Q is in the lower left. So it definitely has point symmetry. Since it has point symmetry, it also has rotational symmetry. So those two go hand in hand. And then let's move on to 7. So for 7, we've got the letter A, and they like to use a lot of different letters of the alphabet to see if you can determine what kind of symmetry it has. Well, this one definitely has line symmetry. I can put a vertical line straight through it right there, and it will fold directly onto itself. They're mirror images of each other. So we're going to mark that as line symmetry. Does it have point symmetry? So here's my north. Notice that right now the top of the A is up here and the 2 legs are over here. So for it to have point symmetry, I have to rotate it 180 degrees for it to look identical to itself. And that clearly is not an A, it's an upside down A. So it does not have point symmetry, and it doesn't have rotational symmetry either, because as I rotate this, it takes a full 180 degrees before it becomes itself again. So all this one has is line symmetry. And then we're going to move on to number 8. Number 8 is like a lightning bolt. It does not have line symmetry. There's no way that I can put a vertical, horizontal, or a diagonal line through it and have it fold onto itself. I'm going to put my north right here, and notice that the thunderbolt, the big upper part of the thunderbolt, is here in the upper left, and it goes down to the lower right. So for it to have point symmetry, I would have to rotate it 180 degrees, and you can see that the big part of the thunderbolt is now down here, and the smaller part is up here, so it did not rotate onto itself. And in fact, keep having the dueling laser lightsabers. In fact, there's no way that I can turn it, that it turns onto itself until I do one full complete turn. So this little lightning bolt has no points of symmetry. So it just has nothing. All right, so then what I want you to do is to pause the video, and I want you to go determine number 9 through 20, what each of those are, and check your answers. So pause the video, go through those. It should be pretty quick, and then check your answers. Okay, so number 9 has point and rotational symmetry because you can rotate it 180 degrees and it's just like the original. So it has both. And then number 10 has all of them. If I were to draw a line for the line symmetry, it would be right there. And of course, if I were to rotate it within 180 degrees, it rotates onto itself. So it has both point and rotational. And then R has none for number 11. And then for number 12, this one just has line symmetry, and here's one line that you could draw. I think it's the only line you could draw. And for this little figure, it has both line and then rotational symmetry. And the line that I would draw through it would be a vertical line like that. Missed it a little bit, but you get the idea. If I rotate 180 degrees, does it look like itself? Oh, no, it just doesn't have to be 180. I was thinking a point. If you just rotate it a little bit, there it goes. It's right onto itself. So that's why it doesn't have point symmetry, but it does have rotational symmetry. And then for 14, it has both point and rotational, because if you rotate a Z 180 degrees, it still looks like a Z, but there is no line symmetry to it. And then for 15, you have this shamrock, little bitty, and I don't know, here's one line symmetry you could draw. It's got a horizontal, it's got a diagonal, so it's got a lot of line symmetry. And then it's both point and rotational, because if you rotate it 180 degrees, it looks just like the original. And then for 16, it has point and rotational. Just because of the way the card is drawn, notice that the queen is in the upper right and the lower left. And if I rotate it 180 degrees, the queen is still in the upper right and the lower left. There is no line symmetry though. And then for this figure, it has nothing. It's got nothing. And then for 18, it does have line symmetry, and the line symmetry would be a horizontal line going through there. And then for 19, it has rotational symmetry, because if I rotate it just a third of a turn, it rotates onto itself. But if I rotate it 180 degrees, it does not look like itself, which is why it does not have point symmetry. And of course, there's no line symmetry that you can draw in there. And then for 20, we have the snowflake. It has everything. It has a ton of different types of line symmetries. So I'm going to draw this diagonal just to be different. But there's one. And then it has point symmetry, because if I rotate it 180 degrees, it looks the same. And so since it has point symmetry, it also has rotational symmetry. So good job with symmetry. So the first half of your notes is over with. You do have homework associated with this symmetry. It should also be quick, but we're going to go and move on and look at dilations. All right, so for dilations, let me get this situated. And by the way, if I didn't mention it before, this is considered lesson 9-4. We put symmetry and dilations together. So for dilations, we are going to either take a figure, and as in this case, we went from a larger figure and we dilated it smaller. Dilations can be small, they don't have to be bigger, but this is your pre-image and this is your image. And so dilations is the only transformation that we've looked at that changes the shape of your pre-image. So the enlargement or reduction, because we can have both, of a figure means a dilation. The dilation is going to have something called a scale factor. It will indicate how much the figure will enlarge or reduce. The variable for your scale factor is known as K. Why? I don't know. I didn't make that up. And so when K is greater than 1, the dilation is going to be an enlargement, which makes sense. And then when K is less than 1, it's going to be a reduction. And we're talking about positive values here. So a number less than 1 is going to be between 0 and 1. And a number greater than 1 is going to be anything greater than 1. It can be a fraction, a decimal, an integer. That's fine. Really more like a whole number since we're not going to do negatives. Okay, so let's go ahead and look at example 1. Okay, so our scale factor on number 1 is 2. So essentially we're going to multiply every single x and y in our ordered pair by 2. So let's just start with plotting our pre-image. So r is going to be left 5, up 1, and s is going to be left 3, up 4, and then t is right 2, and then down 1. And then I'm going to connect with a straight edge. Okay, so then to get our image, that's our pre-image, to get our image, we're going to multiply this by 2, this by 2, and so forth. So negative 5 times 2 and 1 times 2 is going to give us, for our prime, negative 10 and positive 2. And then I'm going to multiply these 2 by 2. So for s prime, I get negative 6 and positive 8. And then I'm going to multiply these 2 by 2. So I get for t prime positive 4 and negative 2. So we should see a bigger figure because with k being equal to 2, that's greater than 1. So we should see an enlargement. So we're going to go left 10 and then up 2. So here is our r prime, and then left 6, and then up 8 gives us s prime, and then right 4 and down 2 gives us t prime. And so I'm going to connect those with a straight edge. And shade that in. Let me get that bigger shading. And there we go. Okay, so that's our dilation for number 1. And then I'm going to do number 3 with you. Of course, not everything went with it. Give me a minute to get rid of that. Okay, so we're going to graph our pre-image first. So for J, we're going to go left 10, up 2. And K, left 2, up 8. And for L, right 6 and up 2. And for M, left 2, down 4. All right, so I'm going to connect those with a straight edge. Okay, so with a k of 1/2, I expect that we are going to have a reduction. So each one of these are going to be divided by 2 because multiplying by 1/2 is the same as dividing by 2. So I'm going to just divide each of these by 2. Okay, and so for our image, for j prime, we're going to get -5, +1. For k prime, -1, +4. For L prime, 3, 1. M prime is going to be -1, -2. All right, we're going to plot those. So for j prime, we're going to go left 5 and up 1. And then for k prime, left 1, up 4. And L prime is to the right 3 and up 1. And for M prime, left 1, down 2. So connect those with a straight edge. Oh, that was fun. Okay, and then let's shade that in. Okay, so then what I would like you to do is pause the video, and I want you to do number 2 and number 4 on your own. So go ahead and pause the video. So here's your answer for number 2. Please pause if you need to fix anything, but you should have had an enlargement, and make sure that you check your ordered pair numbers. For number 4, we had a reduction, and I like number 4 because some of your answers here turned out to be fractions. And now for like for x prime, 10 divided by 4, it reduces to the improper fraction. 2 divides into both of these. It reduces to 5/2, but it's easier to plot 5/2 if you think of it as a mixed number. So 5/2 as a mixed number is 2 1/2. And then of course over here you ended up with -2/4. 2 divides into both of those, and that gives you -1/2, not -2. This one's -2. So make sure that you're dividing appropriately. If you're struggling with these operations, use your calculator. Remember that TI, you can do math, enter. All right, so then we're gonna move on to the second page, and we'll do a couple on that side as well. So on this side, we're not actually going to do number 5, but I want to talk about how you would do it if you have a scale factor that's a fun one, like 5/2. Because on the other side of the notes, we had, either 4 or 1/4. 4, you just multiply everything by 4. 1/4, multiplying by 1/4 is the same as dividing by 4. But what happens when you have something like this? It's a fraction, but it's not over 1 or under 1. So here's what you would do. You would take each of your pre-image points, like for instance, here's D, 0, and then comma 0. So I would save some room there, and you're just going to multiply each of these by 5/2 and 5/2. Well, obviously 0 times anything is going to give you 0, so D prime would still be 0 and 0. And then for E, I'm going to take 2 and I'm going to put it over 1, and then I'm going to multiply it by 5/2, and then comma 4, and I'm going to put that over 1, and I'm going to multiply that by 5/2. And again, you can use your calculator to help you do the math, but for instance here, the 2's cancel, and you end up with 5/1, which is just 5. And here, 2 cancels into 2 once, 2 cancels into 4 twice, and you end up with 2 times 5 is 10, over 1 times 1, which is 1. So you end up with 10. And now I do want to point out that this is a fraction greater than 1, so you should end up with an enlargement, which makes sense why we end up with an ordered pair further out here than you did at 2, 4. And then if we were going to do F, so we're going to take 6 and put it over 1, and then multiply that by 5 halves, and then take 2 and put it over 1, and multiply that by 5 halves, and go through the math again. So 2 goes into 2 once, 2 goes into 6 3 times. So we would have 3 times 5 is 15. And then on the y term, the 2's cancel. You end up with 5 over 1, which is 5. And then finally for g, we'll put g over here since we're not actually graphing it. For g, I would take 4, put it over 1, and multiply it by 5 over 2. And then take negative 2 over 1 and multiply that by 5 over 2. And then we're going to do the math. So 2 goes into 2 once, 2 goes into 4 twice, 2 times 5 is 10, over 1 is 10. And then here the 2's are going to cancel, but don't forget you have a negative times 5, so it gives you negative 5. And of course you would graph your pre-image, graph these image points, and you would be done. But I did want to demonstrate how do you deal with a k that's, you know, a funkier fraction. It's not 1 over something. All right, so then let's move on to a little bit different type of problem. So as you look at number 7, they're asking you to graph the image of the parallelogram below using a scale factor of k equals 2. They have given you the pre-image, but they haven't told you what the ordered pairs are. You do know what the scale factor is. So I'm going to write out the ordered pairs for M, N, O, and P. So as you look at M, we are going to the left 1 and up 3. So left 1, up 3. And then for N, we are going to the right 1 and up 4. So right 1, up 4. And then for O, we are going left 2, down 1. So here would be left 2, down 1. And finally for P, we are going to go left 2, 3, 4, down 2. So left 4, down 2. So then because our scale factor is 2, I am going to just multiply every single x and y by 2, and we'll get these values. So negative 1 times 2 is negative 2, 3 times 2 is 6, and then for n prime, 1 times 2 is 2, 4 times 2 is 8. For O prime, negative 2 times 2 is negative 4, negative 1 times 2 is negative 2. For P prime, negative 4 times 2 is negative 8, and negative 2 times 2 is negative 4. So let's plot these. M prime is going to be to the left 2 and up 2, 4, 6. So we should be expecting an enlargement because k is greater than 1, so that looks right. And then for n prime, we're going to go to the right 2 and up 8. So that's n prime. And then for O prime, we're going to go to the left 4 and down 2. It's right where P is. And finally for P, we're going to go left 8 and down to 4. So here's P prime. We're going to connect those with a straight edge. And we're going to shade that. And voila, we're done. So then what I would like you to do is try, I'm going to have you try number 9 because it's going to be a fun fraction, but I'll get you started on it a little bit. So as you do number 9, I'll do Q with you, and then you can stop and do the rest on your own. So the original Q is, if you look at the ordered pair, because this is such a funky fraction, I'm going to actually physically write it out. So Q is left 1, up 4, so we have -1, 4. So I'm going to take -1. Typically I'll do it over 1 when I'm multiplying by an improper fraction. And then it is up 4, so we have 4 over 1. Pay attention to your signs, and then times 3 over 2. So do your math. -1 times anything is just going to change the sign. So this one's going to become -3/2, which is -1.5, because it's a lot easier to graph the mixed number than it is the improper, so I'm going to write it that way. And then for your y value, 2 goes into 2 once, 2 goes into 4 twice, so that leaves us with 2 times 3 is 6. And so we would go to the left 1.5 and up 2, 4, 6, so we would be right here for Q prime. Okay, so I want you to stop the video and I want you to finish the other 3 on your own. And here is your answer for number 9. Actually, the other 3 multiplying by 3/2 was not as difficult as Q was, but hopefully you get the idea. All right, so then the last one I'm going to do with you is 11 and 12. I'm going to do 11 with you, and you're going to do 12. So for 11 and 12, the only difference is you are identifying the scale factor used to graph the image below. So you see the pre-image here, and then you see the image here. So what you're going to do is you're just going to pick one ordered pair. Your job is to find K. So you're going to pick one ordered pair. So I'm going to choose D and D prime. And we are going to take the image and divide it by the pre-image. So for instance, my image for D prime, so I'm going to take D prime here, and I'm going to put its ordered pair. So the ordered pair for D prime is 0, +2. And then I'm going to divide it by my image, which is D. And then the ordered pair for my image is 0. And then what? 2, 4, 6, comma 6. Because I know, let me finish that off. So it's kind of hard on this one because you got 0 divided by 0. Well, that's 0. So that one doesn't really count because we don't know what we divided each of these by to get to 0, because 0 divided by anything is going to be 0. Same thing as 0 multiplied by anything is going to be 0. So really on this particular ordered pair, we want to focus here. 2 divided by 6, well, what goes into both of those? 2. So 2 goes into 2 once, 2 goes into 6 3 times. So K must have been 1/3. And so since this is our final image here, right, we must have had a reduction, which makes sense that we would have a fraction of 1/3. So now always take your image and divide it by your pre-image. So then I want you to choose any ordered pair over here with number 12, and you determine what you're going to get, because I want you to notice that your image this time is here, right? So you must have an enlargement. So you should end up with a K. I'm going to make this a whole lot bigger. You should end up with a K that's bigger than 1. Let me finish filling this in. Yes, I can color inside the lines. Apparently not very well. See if I can erase that part. See, it looks so much better now. For those of you who this would bother, there you go, I fixed it. Oh, and there's one over there. Okay, so Now, pause the video. I want you to choose either W, X, Y, or Z and take the image and divide it by the pre-image. So pause the video. So here is your answer for number 12. Your scale factor should be 4, which we anticipated because we do have an enlargement. Here's your pre-image and here's your enlarged image. And both of these, -8 divided by -2, turns out to be 4/1. +8 over +2 turns out to be 4/1. We will not write the scale factor over 1, so it turns out to be just 4. So then you will have an assignment for dilations. And if you have any issues, questions, or concerns, don't hesitate to text me or come in for help. Have a good day.